All right, hello everyone, and welcome to my channel. This is an educational channel, and we delve into great theories of everything, cosmologies, generalized theories that you can benefit from, helping you out with your paradigm shifting, your awakening to 5D consciousness, your arrival at a holistic worldview. And today is our 521st video that we've done on the reciprocal system of theory from Dewey B. Larson, also known as the universe of motion, because Larson was one of the only scientists who has attempted to construct his universe upon motion. And he has distinguished himself from even those people like Descartes and Hobbes by defining motion as the relationship, the reciprocal relationship between space and time. And so in 1959, Larson put out his two fundamental postulates where he boiled down how the universe operated. And the first of those two postulates is the main one, where he says that the universe is composed entirely of one component, motion, existing in 3 dimensions, in discrete units, and with 2 reciprocal aspects, space and time. Okay, so motion is a fraction with space or time as the numerator and time or space as the denominator. You can think of speed. The runner is running 10 miles an hour, 10 miles of space in 1 hour of time. Space over time is speed. But Larson applies that to all of our scientific phenomena. They're all forms of motion. They all can be described in space-time terms. For example, matter in Larson's system is time to the 3rd power over space to the 3rd power. And energy is simply time over space. Acceleration is space over time squared. Force is time over space squared. And so on and so forth. Now, also, Larson, when he speaks of motion, he's speaking of a more generalized kind of motion that he calls scalar motion. Scalar motion is a motion that has a magnitude but has no specific direction. He actually used the term change later in his life. He died back in 1990. Change in 3 dimensions. But scalar motion can be envisioned using a balloon, which you put dots on. If you blow up the balloon, all the dots are moving away from one another. But they're not moving in any specific direction, just either out or in. Every dot is moving away from every other dot, meaning that every dot is moving in every direction, outward. If you contract the balloon, then every dot will be moving in every direction inward. So it's either in or out, but nothing in particular motion, direction-wise. The outward motion Larson refers to as the progression. The inward motion he refers to as gravitation. Those are the 2 main forms of motion, but motion can take 4 different motions. You can have a translational motion, you can have a vibrational motion, you can have a rotational motion, and you can have a rotational vibration. And they're all really the same from a scalar standpoint. Now, if you want to get further into Larson's theory, you want to watch one of my first 474 videos on this subject. Today, we're looking at hopefully the last installment of his book called Basic Properties of Matter, where he takes his 2 fundamental postulates, derives a theoretical universe from it, and then compares his theoretical universe with that of the empirical universe of the modern scientists, and that they've compiled in their tables and so on. So This book is on chemistry. He looks at many of the basic properties of matter, arrives at equations for them, and then compares them with the tables. We are actually in the last chapter here that is called Mass and Energy, which we started yesterday. And so hopefully we can wrap this up today if I get started right now. But again, if you want the background, you want to watch one of my first 474 videos. I'm going to basically assume that you have some background here for the remainder of this video. Larson might catch you up, get you up to speed here with some of his explanations. Otherwise, if you're comfortable with the unknown, you can just stay tuned in. Okay, while the thermal disintegration process is operative in every star, it does not necessarily proceed all the way to destruction of the star. The extent to which the mass of the star and consequently the temperature increases depends on its environment. Some stars will accrete enough mass to reach the temperature limit and explode. Others will not, but the increase in magnetic ionization level is a continuing process in all environments, and it necessarily results in arrival at the magnetic destructive limit when sufficient time has elapsed. This limit is thus essentially an age limit. A process related to those that have been described in the foregoing paragraphs is the sequence of events that counterbalances the conversion of three-dimensional motion or mass into one-dimensional motion or energy in the stars. The energy that is generated by atomic disintegration leaves the stars in the form of radiation. According to present-day views, this radiation moves outward at the speed of light, and most of it eventually disappears into the depths of space. The theory of the universe of motion gives us a very different picture. It tells us that inasmuch as the photons of radiation have no capability of independent motion relative to the natural datum, they remain stationary in the natural reference system or move inward at the speed of the emitting object. Each photon, therefore, eventually encounters or is absorbed by an atom of matter. The net result of the generation of stellar energy by atomic disintegration is thus an increase in the thermal energy of other matter. As will be explained in Volume 3, the matter of the universe is subject to a continuing process of aggregation under the influence of gravitation. Consequently, all matter in the material sector, with the added thermal energy, is ultimately absorbed by one of the giant galaxies that are the end products of the aggregation process. When supernova explosions in the interior of one of these giant galaxies become frequent enough to raise the average particle speed above the unit level, some of the full units of speed thus made available are converted into rotational motion, creating cosmic atoms and particles. This cosmic atom building, which theoretically operates on a very large scale in the galactic interiors, has been observed on a small scale in experiments, the results of which were discussed in Volume 1. In the experiments, the high energy conditions are only transient, and the cosmic atoms and particles that are produced from the high level kinetic energy quickly decay into particles of the material system. Some such decays no doubt also occur in the galactic interiors, but in this case the high energy condition is quasi-permanent, favoring continued existence of the cosmic units until ejection of the quasar takes place. In any event, the production of these rotational combinations has increased the amount of existing cosmic or ordinary matter at the expense of the amount of existing energy, thus reversing the effect of the production of energy by disintegration of atoms of matter. In concluding this last chapter of a volume dealing with the properties of matter, it will be appropriate to call attention to the significant difference between the role that matter plays in conventional physical theory and its status in the theory of the universe of motion. With the universe of present-day physical science in a universe of matter, one in which the presence of matter is the central fact of physical existence. In this universe of matter, space and time provide the background or setting for the action of the universe. That is, according to this view, physical phenomena take place in space and in time. As Newton saw them, space and time were permanent and unchanging, independent of each other and of the physical activity taking place in them. Space was assumed to be Euclidean, and time was assumed to flow uniformly and unidirectionally. All magnitudes, both of space and time, were regarded as absolute, that is, not dependent on the conditions under which they are measured, or on the manner of measurement. A subsequent extension of the theory, designed to account for some observations not covered in the original version, assumed that space is filled with an imponderable fluid, the ether, which interacts with physical objects. Einstein's relativity theories, which have replaced Newton's theory as the generally accepted view of theoretical physicists, retain Newton's concept of the general nature of space and time. To Einstein, these entities constitute a background for the action of the universe, just as they did for Newton. Instead of being a three-dimensional space and a one-dimensional time independent of each other, as they were for Newton, they are amalgamated into a four-dimensional space-time in Einstein's system, but they still have exactly the same function. They form the framework or container within which physical entities exist and physical events take place. Furthermore, these basic physical entities and phenomena are essentially identical with those that exist in Newton's universe. It is commonly asserted that Einstein eliminated the ether from physical theory. In fact, however, what he actually did was to eliminate the name ether and to apply the name space to the concept previously called the ether. Einstein's space has the same kind of properties that were formerly assigned to the ether, as he admits in the following statement, quote, "We may say that according to the general theory of relativity, space is endowed with physical qualities. In this sense, therefore, there still exists an ether," end quote. The downfall of Newtonian physics was due to a gradual accumulation of discrepancies between theory and observation, the most critical being the results of the Michelson-Morley experiment and the measurements of the advance of the perihelion of Mercury, neither of which could be explained within the limits of Newton's system. Some modification of that system was obviously necessary. The question as it stood around the end of the 19th century was what form of the revision of Newton's ideas should take. As brought out in Chapter 13, in order to qualify as theory in the full meaning of the term, the treatment of a physical phenomenon must cover not only its mathematical aspects, but also its physical aspects. That is, it must provide a conceptual understanding of the entities and relations to which the mathematics refer. However, the general tendency in recent years has been to concentrate on the mathematical development and to omit the parallel conceptual development, substituting conceptual interpretations of the individual mathematical results. Richard Feynman describes the present situation in this manner. Quote, "Every one of our laws is a purely mathematical statement in rather complex and abstruse mathematics." End quote. In his attack on the problem of revising Newton's theory, Einstein not only adopted this policy of widening the latitude for theory construction by restricting his development to the mathematical aspects of the subject under consideration, and thereby avoiding any conceptual limitations on his basic assumptions, but went a step farther and loosened the normal mathematical constraints as well. He first introduced a high degree of flexibility into the numerical values by discarding the idea that coordinates must have an immediate metrical meaning, an expression that he defines as the existence of a specific relationship between differences of coordinates and measurable lengths and times. As C. Moeller describes this theoretical picture, quote, in accelerated systems of reference, the spatial and temporal coordinates thus lose every physical significance. They simply represent a certain arbitrary but unambiguous numbering of physical events, end quote. Along with this flexibility of physical measurement, which greatly increased the latitude for making additional assumptions, Einstein introduced a similar flexibility into the geometry of space-time by assuming that it is distorted or curved by the presence of matter. The particular aim of this expedient was to provide a means of dealing with gravitation, a key issue in the general problem. One textbook explains the new view in this manner. What we call a gravitational field is equivalent to a warping of time and space, as if it were a rubbery sort of material that stretched out of shape near heavy bodies. That's a quote. That's the end of the quote. The basis for this assertion is an assumption. The assumption that, for some unspecified reason, space and matter exert an influence upon each other. Quote, space acts on matter, telling it how to move. In turn, matter acts on space, telling it how to curve, end quote. But neither Einstein nor his successors have given us any explanation of how such interactions are supposed to take place, how space tells matter, or vice versa. Nor does the theory explain inertia, an aspect of the gravitational situation that has given the theorists considerable trouble. As Abraham Pais sums up this situation, quote, it must also be said that the origin of inertia is and remains the most obscure subject in the theory of particles and fields, end quote. Today, there is a tendency to call upon Mach's principle, which attributes the local behavior of matter to the influence of the total quantity of matter in the universe. Meissner, Thorne, and Wheeler say that, quote, Einstein's theory identifies gravitation as the mechanism by which matter there, the distant stars, influences inertia here. End quote. But this is all within a quote. No, it isn't. It's just, that's the end of the quote. But as indicated in the statement by Pais, this explanation is far from being persuasive. It obviously gives us no answer to the question that baffled Newton. How does gravitation originate? Indeed, there is something incongruous about the acceptance of Mach's principle in the same scientific community that is so strongly opposed to the concept of action at a distance. The fact is that neither Newton's theory nor Einstein's theory tells us anything about the mechanism of gravitation. Both take the existence of mass as something that has to be accepted as a given feature of the universe, and both require that we accept the fact that masses gravitate without any explanation as to how or why this takes place. The only significant difference between the two theories in this respect is that Newton's theory gives us no reason why masses gravitate, whereas Einstein's theory gives us no reason why masses cause the distortion of space that is asserted to be the reason for gravitation. As Feynman sums up the situation, quote, "There is no model of the theory of gravitation today other than the mathematical form," end quote. The concept of a universe of motion now provides a gravitational theory that not only explains the gravitational mechanism, but also clarifies its background, showing that mass is a necessary consequence of the basic structure of the universe and does not have to be accepted as unexplainable. This theory is based on a new and totally different view of the status of space and time in the physical universe. Both Newton and Einstein saw space and time as the container for the constituents of the universe. In the theory of the universe of motion, on the other hand, space and time are the constituents of the universe, and there is no container. On this basis, the space of the conventional spatiotemporal reference system is just a reference system, nothing more. Thus, it cannot be curved or otherwise altered by the presence of action of anything physical. The presence or action of anything physical. Furthermore, since the coordinates of the reference system are merely representations of existing physical magnitudes, they automatically have the metrical meaning that Einstein eliminated from his theory to attain the flexibility without which it could not be fitted to the observations. The theory of the universe of motion is the first physical theory that actually explains the existence of gravitation. It demonstrates that the gravitational motion is a necessary consequence of the properties of space and time, and that the same thing that makes an atom, the rotationally distributed scalar motion, also causes it to gravitate. Additionally, the same motion that is responsible for inertia. Of course, this return to absolute magnitudes and mathematical rigidity invalidates the conceptual interpretations of Einstein's solution of the problems raised by the observed deviation from the consequences of Newton's theory and requires finding new answers to these problems. But these answers have emerged easily and naturally during the course of the development of the details of the new theory. In most cases, no changes in the existing formulation of the mathematical relations have been required. While Einstein's modification of Newton's theory was almost entirely mathematical, our modification of Newton-Einstein's system is primarily conceptual, because the errors in currently accepted theory are nearly all in the conceptual interpretation of the observations and measurements, that is, in the prevailing understanding of the meaning of the mathematical terms and the relations between them. The changes that the new theory makes in the conceptual aspects of the gravitational situation do not affect any of the valid mathematical results of Einstein's theory. For example, most of the mathematical consequences of the general theory of relativity that have led to its acceptance by the scientific community are derived from one of its postulates, the principle of equivalence, which states that gravitation is the equivalent of an accelerated motion. In the theory of the universe of motion, gravitation is an accelerated motion. It follows that any conclusion that can legitimately be drawn from the principle of equivalence, such as the existence of gravitational redshifts, can likewise be derived from the postulates of the theory of the universe of motion in exactly the same form. The agreement between the two theories that exists in these subsidiary areas and in the mathematical results does not extend to the fundamentals of gravitation. Here, the theories are far apart. The theoretical development reported in the several volumes of this work shows that the attempt to resolve physical issues by mathematical means, the path that has heretofore been followed in dealing with fundamental physics, precludes any significant conceptual changes in theory, whereas, as our findings have demonstrated, there are major errors in the basic assumptions upon which the mathematical theories have been constructed. Until comparatively recently, it was not feasible to locate and correct these errors, because access to a large amount of factual information is indispensable to such an undertaking, and the available supply of information was simply not adequate. Continued research has overcome this obstacle, and the development of the theory of the universe of motion has now identified the machinery, not only of gravitation, but of physical processes in general. We are now able to identify the common denominator of all of the fundamental physical entities, and by defining it, we define the entire structure of the physical universe. Okay, that's the end of this book, Basic Properties of Matter, by Dewey B. Larson, one of his works on chemistry. This is volume 2 of his 3-volume The Structure of the Physical Universe, second edition, which he wrote in the 1980s, when he was in his 80s. And the third volume is called we've covered the first volume, Nothing But Motion, and the second volume, Basic Properties of Matter. The third volume is called Universe of Motion, and it is on astronomy. That is a little bit more advanced study, and also extremely long. And so we will get into it probably a little bit, but I don't know that we're going to cover that whole book. We did read one of my articles on his theory of astronomy to just kind of sum it up. And we might look at a chapter here or there, but I don't know that we're... I would say that the Universe of Motion, along with a lot of KVK Nehru's articles, are more of a kind of a graduate school level, if this is an undergrad level study. So that might be for a little bit later time to get into his theory of astronomy is outstanding. You know, I love it, but it takes some intense study to kind of get it, I think. At least for me, maybe I'm just a layperson, liberal arts person, and maybe I'm lacking my scientific foundation, but probably not. And it's just hard. So we'll get into it later. But what we're going to move into next, we're going to continue on with the Larson for maybe a couple more months. But we're going to get into one of Larson's books on economics. And this one is called The Road to Permanent Prosperity. And I don't believe that we're going to read the entire book into the record like we have with other of Larson's books. In those cases, I've shied away from kind of trying to summarize the book and just including things I think are important, because my expertise on some of these subjects is, and my understanding of Larson's system is not to the point where I feel like I'm able to editorialize in that way. But with his book on economics, it's a little bit closer to my wheelhouse, and it's also a very long study, and so I'm going to try to condense it into You know, certainly not one episode, but, you know, maybe one episode per chapter or something like that. I'm going to try to condense Larson's theory. We might read the introduction tomorrow and then go from there. So we'll have to see how it goes, but I'm going to try to move through the material as fast as I can, but also getting the general idea of it. And from there, we're going to look at some of Bruce Perret's RS2 material again, look into some of his forum posts, his important forum posts that he did on some of the forums that he wrote on before he died, the Antiquitas forum, the Conscious Hugs forum, and the RS2 theory forum. So that'll be coming up, and then we're going to move into some other stuff, synergetic geometry from Buckminster Fuller. We're going to look at his book Synergetics, his magnum opus, and then we're also going to look at some quantum arithmetic, some music theory, some ancient history, and many other things, hopefully before the end of the year. So like, share, subscribe, and tune in. Thanks for tuning in today, and hopefully we'll see you next time with the universe of the road to permanent prosperity. Thanks for tuning in. Have a great day.